Okay, pre-cal students, in this video we're going to start our journey into looking at many trig identities. Now, instead of giving a definition of what a trig identity is, let's just jump right into these, and I believe they'll make sense, and you'll kind of understand what a trig identity is. Now, you'll need your textbooks today, so go ahead and get out your textbooks and write your heading down if you would. Our heading today is Basic Trig Identities and Cofunction Identities, okay? Basic Trig Identities and Cofunction Identities. Be sure and include today's date so that you have organized notes, and also understand that we are looking at two different types of trig identities today. One of those groups will be your basic trig identities, and the other group will be cofunction identities, okay? All right, here we go. Go ahead and open your books, if you would please, to page 568. Turn in your books to page 568, and when you do that, right in the middle, you should see these identities right here. Now, I want to go ahead and tell you something you need to know. I am not going to make you memorize these identities. You're welcome to have what I call a cheat sheet to use for tests and quizzes, but I would go ahead and start making your sheet right now. And before these 3 chapters of trigonometry is over, you will have probably filled up the front and maybe the back of a sheet of notebook paper with a bunch of these trig identities. Okay, I'm back. Sorry about that interruption. Someone was calling on the phone. But anyways, moving on. So I would encourage you right now during the video, why not go ahead and get out a blank sheet of paper and up top put trig identity cheat sheet or trig identity sheet, and start copying these down, because you're going to need these for your tests and quizzes. And you may as well go ahead now and copy these down. Now, first of all, these 6 here are called the whole entire section here is called your basic trig identities, or your fundamental trig identities. And right here, we call these the reciprocal identities. And you should be familiar with these, okay? I mean, you've been taught since we started trigonometry that sine is the inverse of cosecant, and cosecant is the inverse of sine, and cosine is the inverse of secant, and secant is the inverse of cosine. Tangent is the inverse of cotangent, and cotangent is the inverse of tangent. So what I'm saying is this. If you had an expression in which you had sine theta, or any unknown, sine x, sine theta, whatever, and you wanted to make a substitution for this, you could substitute 1 over cosecant theta, which is what this is saying right here. Sine theta equals 1 over cosecant theta. And that's true. We know that. Cosecant theta equals 1 over sine theta. Okay? Pretty cool. Now, I'm not going to get into a whole lot of proofs, but let me show you something down here. These are called the quotient identities, and you have not, more than likely, seen these before. Tangent equals sine over cosine. Now, let me very quickly show you where they got this from. And you know, having just said that, let's hold off on that, because I really want to focus on going over these and not chasing a bunch of rabbit trails right now. So let's hold off on that. But the main thing you need to see here, and sometimes I do get caught up in the proofs and being a little too long-winded, so let's just put that on hold for now. But tangent equals sine over cosine. That's a trig identity you will use a lot, and you've never seen that before. Cotangent equals sine over cosine over sine. Cotangent equals cosine over sine. Pretty cool. Okay, and then look at these 3 trig identities down here. These are called the Pythagorean identities. The Pythagorean identities, okay? And they actually get these from the Pythagorean theorem. We won't go into detail on that right now, but sine squared plus cosine squared. Now notice you have to have the same angle, okay? Sine squared of a given angle plus cosine squared of the same angle equals 1. 1 plus tangent squared of an angle equals secant squared of the same angle. 1 plus cotangent squared equals cosecant squared of the same angle. These are trig identities you need to be very familiar with, and these are your basic or your fundamental trig identities. Now we're going to use these in a second in some problems, okay? So if I were you, I would pause the video, I would go ahead and start your trig identity sheet and keep this for the rest of the year, okay? All right, let's continue on. Now on this same page, if you'll look up at the top of your page, I took a picture of these. You should see this at the top of your page. These are called the cofunction identities. The cofunction identities. And what they're saying is this. Please don't miss this. If you have cosine of an angle, and you take that angle and take 90 minus that angle, they will equal each other. Now this looks a little confusing, but I will explain this a lot better in just a second, okay? If you have the cotangent of an angle and you take the tangent of 90 minus this angle right here, you will get an equivalent or an equal expression. If you have the cosecant of an angle and you take the secant of 90 minus whatever this angle is here, these two sides will equal each other, okay? So let me put it in words you might understand a little better, and I would take some really good notes on this. Anytime you have sine of an angle and cosine of an angle, and let me think here for a second what this would be, 58 degrees. Now it has to be sine and cosine, and these two angles here have to add up to 90. Anytime you have sine of an angle and cosine of another angle in such a way that these two angles add up to 90, then they will be equivalent. And if you don't trust me, then go ahead and take the sine of 32 on your calculator, make sure you're in degrees, hit enter, then take the cosine of 58 degrees and hit enter, and you will get the exact same number on both sides, okay? So you could also say this with tangent. Let's use some different numbers. Let's say the tangent of 40 and the cotangent of 50. As long as you have tangent here and cotangent over here, and these two angles here add up to 90, then those two sides will be equal. And again, if you want to test that, go ahead and type into your calculator, make sure you're in degrees, type in tangent of 40, and then type in cotangent of 50, and you'll get the same answer. And the same thing is true with secant and cosecant. Let's say the secant of 60 equals the cosecant of 90, and that's not correct, sorry about that, the cosecant of 30, okay? So as long as you have the secant on one side and you have cosecant on the other side, and as long as these two angles right here, this angle and this angle, add up to 90 degrees, or same thing in radians for that matter, only it would be pi over 2 instead of 90, but as long as that's true, then these two sides will be equal to each other. And that's what the cofunction identities are stating. So, sine of 90 minus theta equals cosine theta. Or, you could also say, or cosine of 90 minus theta equals sine of theta. That's exactly what these identities are stating, okay? So I hope that makes a little sense and makes these trig identities here a little easier to understand. Now, let's go ahead and try a problem. So copy this in your notes if you would. Let theta be an acute angle, an angle less than 90, such that the sine of theta equals 0.6. Find the other 5 trig function values without drawing a triangle. In other words, use your trig identities. Let me pause and say this. You could solve this without your trig identities. You could say sine of theta equals 0.6, which is the same thing as 6/10, which is the same thing as 3/5. Then you could draw your right triangle, and you could label this angle theta. And remember, sine of theta is opposite over hypotenuse, so your opposite side would be 3, and your hypotenuse would be 5. And then using Pythagorean's theorem, you would see this leg is 4, and then you could find the cosine tangent, cosecant, secant, and cotangent of theta by using your right triangle. But we're going to try this a different way so that we're practicing our trig identity. So I'm going to go back over here. I'm going to grab this box right here. I'm going to pull this here so we can use it a little bit, and we'll put it right down here. And we might need our cofunction identities too. Let's grab those real quick here, and we'll pull those right over here. Now let's go ahead and do this. Let's go ahead and write down sine of theta equals 0.6. And so now our goal is to find the cosine of theta and the tangent of theta and the cosecant of theta and the secant of theta and the cotangent of theta. Now, in my opinion, I think it would be easier if instead of using 0.6, we used a fraction. All right, that's just my opinion. So let's grab 0.6, and 0.6 would be 6/10, which is the same thing as 3/5. Now, using your trig identities, which would be pretty simple to do, let's go ahead and quickly find some of the easier answers. For example, look at your trig identities here and watch this carefully. What do we know about the sine right here and the cosecant? Well, according to your trig identities, they're inverses of each other. So if the sine of theta is 3/5, then the cosecant of theta is, look at that, 5/3. Not too bad. Okay, now we're kind of stumped, but as I glance through my trig identities, I'm thinking, hold it, look at this one right here. Look at this one. Sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. So here we go. I'm thinking, wait a second, sine squared, well, I know what sine sine theta is. Sine theta is 3/5, right? So I square that. So I'm going to put 3/5 squared. And in case you're wondering, that's what sine squared theta means. It means take the sine of theta and square it. So the sine of theta is 3/5 plus cosine squared theta equals 1. Now, let me go ahead and take this box and slide it out of the way and get some room to work here just for a second. Now I'm trying to solve for theta, so I'm going to square this fraction, and I'll get 9/25, correct? And then bring that 9/25 to the other side and make it a negative 9/25, or in other words, subtract 9/25 from both sides, and now you'll have this. You'll have cosine squared theta equals, let's see, 25 minus 9 would be 16/25. There we go. So I bring the 9/25 over, I make it a negative 9/25, and you can use a graphing calculator if you want to. 1 minus 9/25 is 16/25. And now I don't want to know what cosine squared theta is, I want to know what cosine theta is, so we're going to take the square root of both sides. Well, the square root of cosine squared is just cosine, and the square root of 16/25 would be 4/25. Okay? Now in the past you've been taught to use positive negative. We're not going to do that today. Now in the future we'll have to worry about that when we get into angles larger than 90, but for right now it just makes sense that none of your sides of a triangle are going to be negative sides, so we want the positive 4/25. So now you just found the cosine of theta, and that's going to be 4. I'm sorry, I apologize, that is incorrect. Let your old teacher make some mistakes here. It would be 4/5 because you take the square root of 16 and the square root of 25. Sorry about that. And so the cosine of theta is 4/5. Look at that. Now hold it. think of your trig identities. If you'll look at your trig identity sheet, you're going to see that the inverse of cosine is secant. So if cosine of theta is 4/5, then the secant of theta is 5/4. So we're doing really well. Now, we're kind of stumped here. What are we going to do? Well, I have an idea. Do you notice this trig identity right here? Tangent of theta equals sine over cosine. Well, why could we not use that? So here we go. Tangent of theta equals sine theta, that's 3/5, over cosine theta, that's 4/5. So there, now I know what tangent theta is. All that I have to do is take 3/5 and divide that by 4/5, which of course is the same thing as 3/5 times 5/4, and your 5's will cancel, and 1 times 3 is 3, and 1 times 4 is 4, so 3/4. So 3/5 divided by 4/5 is 3/4. So now we know tangent of theta was 3/5 over 4/5, which equals 3/4. So now we know the tangent of theta is 3/4. Now, think about that. Looking at your trig, your fundamental trig identities, or your basic trig identities, if the tangent of theta is 3/4, then the cotangent of theta is the inverse of that, 4/3. There we go. So we found all other 5 trig function values without drawing a triangle by just using our trig identities. Pretty interesting, okay? All right, let's try another problem like this, similar to this one. I would like you to go ahead and turn in your books, if you would please, to page 571. Look at number 32 at the bottom. Now, here's what they're giving you. This is a really difficult problem, so please pay attention. And the next 2 problems we're going to do are also pretty difficult, okay? All right, I believe it says beta here, so we'll just say beta. Tangent of beta equals 5. Or we could just call it b if you want to, which is fine. And they want us to find the following. Cotangent of b, the cosine. This is all in your book if you look at number 32. The tangent of 90 minus b, and then the cosecant of b. Now, let's go ahead and pull our trig identity sheets over here in case we need those. Okay, now this should be a little bit of a help here. This isn't too bad, the first one. I mean, they want us to find the cotangent of b. Well, we know that tangent and cotangent are inverses of each other. So if tangent is 5, which is the same thing as 5 over 1, then the inverse of 5 would be 1/5. So that's pretty easy. Anytime you know the tangent, the inverse of that will be the cotangent. Now let's move on to cosine. Now I'm having a hard time here because I know tangent, I know cotangent, but I've got to find a trig identity that has tangent and cotangent, one of those, and cosine. And I'm not seeing any of those, but hold it. I noticed this trig identity here. Now this trig identity here has tangent and secant. Now if I can find secant, then the inverse of secant is cosine. So I think this is the route I'm going to go right here. So I'm going to grab these 2 here that I'm supposed to find, and I'm going to pull them over here out of the way. There we go. And I'm going to go ahead and find the secant here. So I'm going to use this formula here. 1 plus tangent squared equals secant squared. Now, watch what happens, okay? For tangent squared, tangent of course is b, so really what I have is 1 plus 5 squared equals secant squared. Well, 5 squared is 25 plus 1 is 26, so 26 equals secant squared b. Now let's take the square root of both sides, and we're going to get the square root of 26 equals the secant. Now, think about that. If I know what the secant is, I'm going to go ahead and circle this right here in green, and that means we're finished. Remember, we already found the cotangent, and it's 1/5. Now, if I want to find a cosine, I know the secant is square root of 26, or square root of 26 over 1. So if I flip that, then the cosine is going to be 1 over the square root of 26. And of course, I have to multiply the top and the bottom by the square root of 26. And if I do that correctly, I will get the square root of 26 over 26. So there, I just found the cosine of B. Okay, 2 down and 2 to go. Now, take a look at this. They want us to find the tangent of 90 minus B. Okay, let's go back to our cofunction identities right here, and let's enlarge them real quick. Let's take a look at them. Now, and you should have them there on a sheet of paper in front of you. Notice this right here. Look at this. Tangent of 90 minus an angle equals the cotangent of that angle. So, tangent of 90 minus B equals the cotangent of B. And didn't I find that already right here? Sure I did. It's 1/5. So, the answer then has to be 1/5. So I'm cruising right along, okay? If that didn't make sense, don't hesitate to pause the video and watch it again, okay? Or rewind the video and watch it again. And now lastly, we're going to find the cosecant of B. Well, I wish I knew the sign. That would be really helpful if I knew the sign of B, because cosecant is the inverse of sine, but I don't. But I do notice this trig identity right here. Look, 1 plus cotangent squared, and I do know the cotangent of B is 1/5. 1 plus the cotangent squared equals cosecant squared. So, what I can do is I can write 1 plus cotangent squared equals cosecant squared. Can I not do that? It's right there in your trig identity sheet. So now I have 1 plus, now what is the cotangent? It's 1/5. So 1/5 squared equals cosecant squared. Now when you square 1/5, you get 1/25. 1 times 1 is 1, and 5 times 5 is 25. And then if you combine these, you will get 26 over 25 equals cosecant squared of B. All right, and then take the square root of both sides. So you would have the square root of 26 25ths equals cosecant. Well, we don't know the square root of 26, so we're going to leave that alone, but we do know the square root of 25 is 5. So are you allowed to do that? Yes, you are. You can take the square root of the denominator, because you know the square root of 25 is 5, and you can leave the square root of 26 alone. So there's your answer. Square root of 26 over 5. Now in your homework, you're going to have a good deal of these to work with, okay? And you're going to have to practice, 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 and be very creative in how you solve these, okay? But it's really good practice on using your trig identities. We're going to look at 2 more problems and we're finally finished. Let's take a look now at something called verifying trig identities. This is one of the hardest things you'll do in trigonometry. Now we're starting off with some pretty easy ones today, and I believe in your homework you do not have a whole lot of these, maybe 6, 7, 8 of these, something like that, but they're pretty difficult, so take some really good notes. We're going to verify trig identities. Now what we do is this: we make substitutions into the left or right side, and we simplify. Sometimes we'll cross multiply. We'll do whatever we're allowed to do algebraically until we get this side over here identical to this side over here. Okay, and you can manipulate both sides as long as you're using true equivalent substitutions. Now this one here is really simple, and to be honest with you, you should see it right away. Okay, and if you don't be discouraged, but it's really pretty simple. Okay, if you'll look at your basic trig identity sheets here, notice that secant equals 1 over cosine. So where secant is, I'm going to bring down my cosine, and where secant is, I'm going to make a substitution, and I'm going to put 1 over cosine. And of course that still equals 1. So I have cosine times 1 over cosine. Well, cosine, of course, is the same thing as cosine over 1. So cosine over 1 times 1 over cosine, well, that's going to be cosine over cosine equals 1. And of course, anything over itself equals 1. So I have 1 equals 1. Finished. There we go. So we made a substitution. We did some simplifying, and then we ended up with two sides that were equivalent. That's called verifying trig identities. Okay, let's try one more. This one's going to be pretty hard, so please take some really good notes on this. Okay, very important that you do that. I did not mean to do that, of course. So we'll just leave it where it is, and we'll come up here. Now, you don't always want to do this, but in this case here, I think what I'm going to do is I'm going to put cosine squared x over 1, and then I'm going to cross multiply. Now I'm just kind of experimenting, but I think that would help. You're going to learn when you start verifying these trig identities, it really is a lot of trial and error, and there's really no steps I can give you. Okay, you're just going to have to look at things and try to picture what a certain substitution would do to the statement and how it would help you or not help you verify the expression. Okay, but I'm going to go ahead and cross multiply right here, and if I do that correctly, tangent times cosecant would be tangent x cosecant squared x. And then if I take this expression here times 1, anything times 1 is just itself, so I would have tangent x plus cotangent x. Okay, let me grab a drink here real quick. And here we go. Now I notice over here on this side I have two terms, and over here I have one term because they're multiplying times each other, and that's going to be a problem. So I either want to take one term and split them into two, which is pretty difficult to do, or I'm going to take two terms over here and try to combine them into one, which is a little easier to do. So here's what I'm going to do. I'm going to leave the right side alone, okay? Or excuse me, I'm going to leave the left side alone. And over here, I'm going to make this a fraction. Now, if you'll look at your trig identity sheets, tangent is the same thing as sine over cosine, okay? And then cotangent is the same thing as cosine over sine. Now, man, I wish that I had a common denominator. If both of these denominators right here, if both of them were cosine, or if both of them were sine, then I could go ahead and I could combine the two fractions because we're adding them. But they're not. So I'm going to have to think outside the box, and I'm going to do this. If I multiply the top and the bottom of this fraction by sine, I can do that as long as I multiply the top and the bottom by the same thing. Well, if I do that, if I multiply the top by sine, well, sine times sine is sine squared. And if I multiply the bottom by sine, I'll have cosine sine. Now, if I multiply the top and the bottom of this fraction by cosine, watch what I would have. Cosine times cosine is cosine squared. And over here, sine times cosine would be cosine sine. And now I've got a common denominator. So I can add my numerators together. Now don't forget, if you have something like 2/5 plus 1/5. Remember how to do that from your pre-algebra elementary days. You add the numerators and you leave the denominator alone. Okay, so we apply that here also to our trigonometry. We're going to add the numerators, so I would have sine, they're unlike terms, so we're not going to be able to put them together. So sine squared x plus cosine squared x all over cosine x sine x. Now, again, I have a lot of experience with these, so you're probably watching saying, wow, I would have never thought to have done that. And it's just going to take practice and creativity, okay? But notice I've done nothing to this side over here. I'm just leaving it alone. Now, sine squared plus cosine squared. Let's go back to our fundamental trig identities and look at this right here. What is sine squared plus cosine squared? Do you see it right here? It equals 1. So now I'm going to put a 1 for this entire numerator, okay? So now I have 1 over cosine x sine x. Now I'm going to leave that alone. I could try to do some more messing around with that, but I'm going to come over here and I'm going to try to manipulate this side over here so that when I'm all done, I have the same thing here that I have over here. So here we go. First of all, let's think about something I could do. Well, I know this. I know I want to get some 1s up top because I have a 1 in my numerator down here. I'm thinking about this. Tangent is the same thing as what? Sine over cosine, right? Times, and cosecant is the same thing as 1 over sine squared, is it not? Now you're thinking, well, Mr. Earhart, it's a cosecant squared. That's okay. I mean, we know that cosecant right here and sine are inverses of each other. Now it's okay if there's a square here, as long as there's a square here. That's totally fine. And so I notice that I have cosecant squared, and the inverse of cosecant is 1 over sine squared. Hey, I might be onto something here. Look at this. If I multiply these two fractions together, notice you have 1 sine here. It would cancel with your 1 sine here, leaving you with 1 sine. And so now you have 1 times 1, which is 1. And you have cosine times sine. Look at this, which is cosine sine. You did it. You took the one right side over here. Well, first of all, we started off with cross multiplying because we had one fraction on one side and one fraction on the other side. Then after we cross multiplied, we were left with this right here. Okay? And then from there, we realized we could make a substitution for cotangent, make a substitution for tangent, two fractions, and we kind of got a common denominator and put those together. And then we realized sine squared plus cosine squared is 1. And then I stop, and you say, Mr. Earhart, how'd you know to stop there? Well, you really don't. Again, it's trial and error. I just kind of looked at this, and I was like, you know, I've taken this side pretty far. Maybe I'll need to come back over here later and do some more manipulations. Maybe I won't. But I came over here to this side, and I realized, hold it. Over here I've got a 1 up top, so I want to get a 1 up top over here. So for cosecant squared, I'm going to put 1 over sine squared, and then tangent is sine over cosine, and then I realized I could cancel a sine out, and then everything else fell into place after that, okay? So what we're doing here is called verifying trig identities, and I'm telling you, there's really no way to teach this as step by step or certain ways to do this. It's trial and error. Sometimes you'll work the whole problem out and you'll realize it didn't work. You'll have to start over and do it another way. Okay? But we're verifying trig identities. Okay? So in this video, in a quick 10-second review, in this video, we looked at our basic trig identities and our cofunction identities. You should go ahead and start your trig cheat sheet if at all possible. We then learned how to find the 5 trig function values when given one value without drawing a triangle, just using the trig identities. And then we were given a trig value here, and using trig identities, we went ahead and found 4 other trig values. And then, of course, here we're looking at verifying trig identities. Okay? If you have any questions, don't hesitate to call or email, and hopefully this video has been a help to you.